Hi everybody. So in this session, I'm going to solve question from signal and system. Okay. So the question will be, there are many questions which was asked in 2023 in GATE examinations. We are going to just solve them, right? So let us start with very first question. I hope my voice and everything is okay, right? So yeah. So the very first question is in front of your screen. In 2023 in electronics paper, there was 7 questions from signal and system, right? Signal and system. Okay. And let us see how we are going to approach to all the problems. Okay, that is what the main agenda of this session is. Okay, so I'm just going to show you my technique, the my smart technique, how to solve question. Okay, from signal and system, right? So you see here, guys, the very first question is there. Consider a system with you can say that okay, xt and the output by t, and there is some relation between input and output is given, right? So it is a LTI system. Okay, if you consider it is an LTI system, right? But it cannot be the LTI system. I'm just going to show you, right? So here the relationship between by t and xt is given, so you have to investigate causal and time invariant. Okay, two properties you have to investigate. The causal is nothing but what, if you suppose put t equal to 0, right? So you should not get the future value, right? I mean, the system should not be able to anticipate future value. Okay, so then only you can say that system is nothing but. So here if you plug t equal to 0, so it is giving you the value. Suppose you are trying to find the output at t equal to 0, but you are getting some future value here, right? So it cannot be the causal system, right? Because it is anticipating the future. It is just like a astrologer. Okay, it is nothing but an astrologer, you can say, because someone is going to predict your future. It means that that system cannot be the causal system. That is very important to keep in mind. Now the how can we have the causal non-causal, so something which is able to predict the future, right? That is not the causal system. Now let us go for second property, that is time invariant, right? So first of all, what you have to do here is, first of all, you can shift signal xt, right? So you can say that by t is nothing but x e raised to power t minus t naught. Now let us shift what? Let us shift the time here, right? So we can shift here. So t minus t naught, okay, is equal to what? X e raised to power t minus t naught. You can see here these two are not equal, right? Okay, these two are not equal. Since you're shifting the signal, xt, okay, x e raised to power t here, right? So and t is nothing but what here? T is not free. Your time you can say time independent, जो आपका जो variable है time, okay, that is not free. Okay, that is very important to keep in mind. So the answer for this question will be B option, right? So you have to investigate causal and non-causal. So this system is non-causal and time variant. Okay, that is very important. So first of all, what you have to investigate, if you are shifting your signal by t naught, so your output should also shift by t naught. Okay, that is very important to keep in mind. So if you are shifting here the signal by t naught, but here you see both are not equal, so you can say that it is a time varying signal, right? Let us solve this question, question number 27. Okay, the first question, what you have to investigate, guys, you have to just investigate causal as well as the time invariant or time variant property, right? That's it. Okay, so let us take here MT be a strictly band limited signal with a bandwidth of B, right? And energy is given E. Okay, so let us consider here the band limited signal. You can say this is kind of a band limited signal. Okay, it is band limited to minus B to B. Okay, this is your, you can say, massive signal MT, right? Okay, you can say that this is nothing but a massive signal M omega, right? Okay, and whose energy is going to be what? Whose energy you can just find out also. Energy is nothing but from the Parseval relation you can find out minus B to B, this is 1, right? So you can say that 1, okay, d omega, which is going to be what, guys? It will be nothing but 2b by 2 pi, which is nothing but b by pi. Understood? So they are saying that MTB is strictly band limited signal with the energy, okay, you can say with bandwidth B and energy E. So this is the energy of the band limited signal. Now what they have given here is, they are asking the energy in the signal MT times cos omega naught t, right? So if they are multiplying by cos omega naught t to any, you can say, time domain signal, so remember that there will be what, you can use the modulation property, right? In communication system you might have seen these things, right? This is nothing but a band pass signal, okay, kind of. if you are multiplying by cosine, so your spectrum will shifted by what? By this amount, whatever amount is given, by omega naught. You can say omega naught equal to 10b, right? So if you want to find the mt times cos omega naught t, what is the Fourier transform of this? The Fourier transform is going to be, remember, I'm just going to draw directly, right? So this spectrum is going to shift by what? Omega naught, right? Plus omega naught and minus omega naught. So omega naught value is 10b here. So if you add here 10b, right? Okay, you can just do. So 10b is nothing but what? If you are going to add here 10b, so it becomes 9b, and this becomes, so your spectrum is gonna shift here. So this is nothing but 10b, and this is nothing but 9b. This is nothing but 11b, and one more spectrum will be shifting here toward, you can say, plus b, plus omega naught and minus omega naught, right? So you can write this is nothing but minus 10 omega naught, and this is minus 11b. Okay, sorry, this should be 10b, right? And this is nothing but minus 9b. Okay, so you have got two signals, and this will be scaled by 1 by 2. You can, this is going to be scaled by 1 by 2. Now you have got this signal, the spectrum of this signal, right? You can find the energy of this signal, okay, just by using the Parseval relation. So what is that Parseval relation? The Parseval relation is same, that is nothing but 1 by 2 pi integration minus infinity to infinity, and you can consider this is nothing but your x of omega, right? So x of omega whole square d omega, right? So you just find out this and multiply by 2, right? So you will get the energy of that, right? So what it will be, you can see here, guys, it will be nothing but okay, so what you can do here is you just find out the width of this. What is the width here, guys? It is nothing but, you can say, 2b, right? 2b, and this is nothing but 1, so it is nothing but 2b by 4 plus, in this case also 2b by 4, okay, and upon 2 pi, okay. Don't forget to divide by 1 by 2 pi, because according to the Parseval relation this holds true, right? आगे क्या करेंगे, इसको आप सिंप्लीफाई कर सकते हो. You can simplify, so it becomes nothing but 4b by 4, right? So it is nothing but b by, you can say, 2 pi, right? And b by 2 pi is nothing but E, right? So you can say that your energy is going to be E by 2, right? Your energy will be E by 2. I hope this makes sense, right? So option for this question will be B. So you can see how fast we can solve the question. If you know the Parseval relation, you can solve this question carefully, right? So remember the Parseval relation, you can find the energy, that is nothing but 1 by 2 pi minus infinity to infinity, x of omega whole square d omega, right? So this question is based on modulation property, guys. Modulation property. Okay. And you have to remember that if any time domain signal, you can say xt, if it is being multiplied by the cos omega naught t or sin omega naught t, so it will be shifted. The spectrum is gonna shifted toward plus omega naught and minus omega naught, right? You can say m omega minus omega naught plus m omega plus omega naught by 2. Okay, the amplitude is going to get scaled by half. Okay, so this question was very good question, and this question depends upon the modulation property, right? Let us solve this question. Question number next 28. So this is third question, you can say, from signal and system. The Fourier transform x of omega you have to find, and xt is given, right? So this you have to identify immediately, right? This signal is nothing but a Gaussian function, you can say, right? So what is the Fourier transform Gaussian function? Gaussian only, right? So you should know that if you know this relation at square, the Fourier transform of e raised to power minus at square is nothing but pi by a e raised to power minus omega square by 4a. Since you see here they have given a equal to 1, right? So you just put here, right? So it will be nothing but pi by 1 e raised to power minus omega by 4. Simple. Okay, what is the answer for this question, guys? Root pi e raised to power minus omega square by 4, right? So which option can be correct here? Option C will be correct here. Okay, I think this is very simple question. This was very simple question, right? We'll move to next question, the question number 29, and these are 1 mark questions, so they are very simple. In the table shown below, match the signal type with the spectral characteristic. Okay, so you have to remember, always remember, sampling in one domain. In the last session also I told you, right? Sampling in one domain correspond to periodicity in another domain, right? So sampling remember this, sampling in one domain, okay, correspond to periodicity, okay, in another domain. That is very important. What is the meaning of sampling? If continuous time signal is given, you have to sample it, so it will become discrete. So discrete correspond to periodicity. That is very important. Periodicity correspond to discrete. Okay, so in this case you see continuous, if the signal is continuous, right, the spectral is going to be what? Spectral is going to be what? That is very, very important to keep in mind. Okay, so continuous signal, okay, this is important. So it will correspond to, you can say, aperiodic signal correspond to continuous. That is very important. And discrete correspond to periodic, periodic correspond to, okay, discrete. That is what you have to keep in mind. Now in this situation, you see they have given discrete, so discrete will correspond to periodic. Okay, so third will match to what? Third will match to, and aperiodic will, okay, so third will match to B, you can say, right? See, discrete correspond to periodic. Okay, understood. And periodic correspond to, aperiodic correspond to continuous, right? Continuous correspond to aperiodic, okay, and aperiodic correspond to, so first is A only, right? Okay, these options are wrong then. Next, discrete correspond to periodic, and periodic correspond, so this fourth D only, right? 4D. Okay, all options has got 4D only, right? And now let us take for second, continuous correspond to aperiodic. Okay, so it will go to C, right? So you see option B will be correct for this question. Okay, this is very important to keep in mind. So what is the logic here, guys? Sampling in one domain correspond to periodicity in another domain. So if you have got discrete time signal, right, so the Fourier transform is gonna be always periodic. That is very important to keep in mind. In case of DTFT, you might have seen. In case of DFT also you might have seen. Okay. Chalo, next. So question number 47. This question was from discrete time Fourier series, right? DTFS, or discrete Fourier series, you can say. So consider a discrete time periodic signal. Okay, so they have given discrete time periodic signal n equal to 5. So period is nothing but 5 here. Let us discrete time Fourier series. This is the definition they have given. You see, x of n is given as summation k equal to 0 to 4 ak e raised to power j k 2 pi n by 5. Okay, so this is nothing but a definition. You don't have to worry about that. Okay, ये definition दी हुई है. And how we get the definition? It is nothing but a linear combination of complex sinusoids. Okay, your definition, your x of n is what? X of n is nothing but what? The multiplied by ak. Okay, now they have given some coefficient here. A not equal to 1, a1 is 3j, a2 is 2j, a3 is minus 2j, and a4 is minus 3j. Now what they are asking is the value of, this is very good question for 2 mark, and many students make mistake here, this kind of question, right? So the first line is just a definition, a formal definition that you should know, right? Now they are asking that, they are asking summation n equal to 0 to 4 x of n sine 4 pi n by 5. So the moment they have given, this is a definition, right? This is nothing but a definition, and they are asking what? They have given this, they are asking this. What is this, guys? This is nothing but a definition of what? Definition of coefficient, ak, you can say, right? Because you always study two formulas. One is nothing but a synthesis formula for Fourier transform or a Fourier series, and one formula you study for computing Fourier series coefficients, right? Or you can say the inverse Fourier transform. Okay, so you have to identify that what they are asking. If you're not able to identify, then you will not be able to solve the question. Now the moment you got sign, okay, sign of this kind, right? If you have got sign of this kind, okay, okay, so how can you write this sign? Sign can be written with the help of, you know, Euler relation, you know, e raised to power j omega naught t something kind. Let me show you. तो आपको याद रखना है कि what is that formula? You should remember this formula. X of n summation ak e raised to power jk omega naught n, right? This is the formula over, you can say, k over n. Okay, this is the formula for DFS. And ak, how to find ak? 1 by n summation only, right? Remember, there will be a summation. But in case of continuous time Fourier series, there is a summation definition, okay? But if you want to find the Fourier series coefficient, so you will have to integrate, okay? Because in case of continuous, here everything is discrete. So 1 by n, right? 1 by n x of n e raised to power minus, okay, minus jk omega naught n. This is the formula you see. Okay, over a period only, right? Over a period, n correspond to over a period. Okay. These are the definition. If you know, then life is very simple. Okay. Now let us come back to the question. The question says that you have to find this. Okay. What is missing here, guys? 1 by n is not written. Remember, 1 by n is not written. So 1 by n is nothing but 5. I mean, n is 5. So n has to be multiplied both sides. Okay. So remember, this is important. So let me write here n equal to 0 to 4. Okay. You can write xn times, okay, e raised to power. You can expand using Euler relation. It's a very simple now. What it will be, e raised to power j 4 pi n by 5 minus e raised to power minus j 4 pi n by 5 upon 2j. Okay, upon 2j. Understood? This is very, very important to keep in mind. Okay, now what you can write this as n equal to 0 to 4 x of n. This is where you have to catch. This is where you have to catch. Okay, since you have written, you are using this formula like sine theta equal to e raised to power j theta minus e raised to power minus j theta by 2j. ठीक है, आपको यहाँ पर समझना है what kind of manipulation that you are going to make here, right? आपको ये समझना है what kind of manipulation you are going to make here, right? So since you have been given n, so n is nothing but 5. So what is omega naught, guys? You can find omega naught. Omega naught is nothing but 2 pi by 5, right? So okay, this is omega naught, right? So you can replace this term by omega naught. So that becomes what, guys? 2 pi. So it is nothing but 2 omega naught n. You can write like this. Okay, okay, e raised to power j 2 omega naught n minus e raised to power minus j 2 omega naught n. This is where you have to understand upon 2j. Now you can see here what you can see. This is nothing but what? This is very important to keep in mind, right? This is nothing minus 2 value, and this will give you the k equal to 2 value. Okay, these are the identification. How I am saying that? You have to compare. You have to compare with this. Okay, you have to compare with the actual definition. So if you compare this and this, right? So here, this is minus k. Minus k is nothing but 2. So k equal to minus 2. This is minus k equal to minus 2. So this is nothing but k equal to 2. I hope this makes sense. So this is how you can find out the coefficient. Okay. तो अगर आपको डेफिनेशन आता है, डेफिनेशन से आपको बस क्या करना है, यू हैव टू मैच द कोएफिशिएंट, राइट? यू हैव टू मैच द कोएफिशिएंट फ्रॉम द एक्चुअल डेफिनेशन, एंड व्हेनेवर व्हाट दे आर आस्किंग, यू हैव टू आइडेंटिफाई कि अच्छा दे आर आस्किंग दिस. ठीक है, तो टाइम आप बचा सकते हो एंड यू कैन गेट आंसर, राइट? सो इसका आंसर क्या आ जाएगा? यू कैन गेट हियर x2 इज नथिंग बट व्हाट, गाइस? x2 is nothing but, sorry, this is nothing but what? You can find out what AK is. So I'm just going to write here. Let me erase this. Okay, so what you can do here is you can say that AK is going to be what? AK will be what they have given. So just find A2. A2 is nothing but, in the question itself they have mentioned something, right? A2 is nothing but 2j, right? A2 is nothing but 2j. So A of minus 2 will be what? Minus 2j, right? I hope this makes sense. This is very important to remember. Okay? Okay? Then what you have to do, guys? What you have to do? You can just equate this as n times a minus 2 minus a2 by 2j. Okay? Next, You just put all these value, and what they are asking is n is nothing but 5, a minus 2 is nothing but minus 2 minus 2j upon 2j. Right? If you try to cancel, j gone, right? So it is nothing but 5 into minus 2, which is nothing but minus 10. Okay, so answer for this question is minus 10. I hope this makes sense to all. So what is the learning from this question? The learning from this question is you have to remember the actual definitions, right? And how those definitions came into existence. मैंने क्या बोला? Fourier series के जो भी formulas होते हैं, they are all linear combination of complex exponentials, right? Linear combination of complex exponential. That's how you construct the signal, right? Xt, right? That is nothing but a synthesis equation. And analysis equation is nothing but what? The computation of Fourier series coefficients, right? तो इस क्वेश्चन को करने का सबसे स्मार्ट तरीका यही है. देखो क्या किया मैंने. फर्स्ट ऑफ ऑल यू हैव टू फाइंड आउट व्हाट, यू हैव टू अंडरस्टैंड दैट व्हाट दे आर आस्किंग, राइट? तो गलती कहीं नहीं होगी, इसका आंसर 10 आएगा. देखो, लेट अस मूव टू नेक्स्ट क्वेश्चन. क्वेश्चन नंबर 48. ओके, so what they have given here is let an input xn having discrete time Fourier transform. X of omega is given, that is nothing but, so this is nothing but DTFT they have given, right? Discrete time Fourier transform, and it is passing through LTI system. The frequency response of that is also given. The response by n you have to find. So you know that what, if Fourier transforms are given, right? So output of by n they are asking. Output of by n is nothing but what, guys? You know, just see, by of omega you can say is nothing but x of omega, h of omega. That's it. If in time domain if you are calculating, so by of n is nothing but x of n convolution by of n, sorry, h of n, right? Convolution with the impulse response h of n. That's it. Okay. This is nothing but what is the inverse Fourier transform of this? So x of n you can write this as, this is nothing but, you know, you can say that 1, right? It is 1, right? And it is nothing but what, the value of what you can say. Okay, so you can just find out the inverse Fourier transform and then you can write, but I don't recommend that also. ठीक है, directly आप multiply कर सकते हो. So y of omega will be equal to what, just multiply 1 into 1, that is nothing but 1, and that will, ठीक है. Now question you can get 3, right? So 1 minus 1 by 2 e raised to power j omega. Then what you can do, you can multiply this minus with 1, it is nothing but e raised to power minus j omega. So it will introduce one impulse at here. So this option is already eliminated. This option can also be, you know, e raised to power, yes, correct. Next is okay, now you can multiply with this, so it will become plus 1 by 2 e raised to power j e omega, right? Next, I hope this makes sense. Now you take this, so it will be nothing but plus 2 e raised to power minus 3 j omega. Okay, now you multiply with this, so it is nothing but minus 2 by 3, I mean 2 gone, right? 2 gone here. Okay, e raised to power minus j 5 omega. Understood? So it will be nothing but what, guys? Plus, and this is minus here, right? Plus minus. So which option can be correct here? You can now take the inverse Fourier transform, right? So very clearly you can see here, this is nothing but delta n, and this will give you you can say that minus 1 by 2 delta n minus 2. ठीक है, तो आप देख सकते हो this is delta n. This cannot be the correct answer, right? Okay, you just eliminate, keep eliminating, right? So I believe that and you can add also, because there is 1 by 2 and there is 2, right? So you can say that it will be 5 by 2, yes, 5 by 2. So this will be nothing but plus only, right? So yeah, these options are wrong. So option C will be correct here. Okay. Okay, this is very easy questions. Okay, ठीक है, देखो ये कितना फास्ट हम लोग कर सकते हैं. ठीक है, you can do step by step also, but I'm not going to do, right? Now question number 49, what they are asking again, they have given xt input, some input is given, right? Xt, it is a LTI system, right? And it is passed through some st. What is the output they are asking? So you know that from the concept, this is a concept, okay? If input is sinusoidal, right? If input is sinusoidal or cosinusoidal or complex sinusoids, output will also be what? A times 10 cos 10.5 omega naught t. I mean, the frequency should be same, right? The frequency should be same. Here, output does not introduce, I mean, in this system does not introduce any sort of phase, right? So don't worry about that. Phase is 0 only, right? ठीक है. अब आपको क्या फाइंड करना है? A की वैल्यू फाइंड करना है. Just multiply with this. Okay, you will get the answer. And this frequency should match. Yeah, all the options have same frequency. Output frequency should match. This is the property of LTI system. Okay, this is the property of LTI system. Okay, if input is given as sinusoidal, so output is going to be sinusoidal. Okay, now how to find this output? I mean this amplitude, right? So you have to first solve this impulse response h of t, right? And you have to find the magnitude at 10.5 omega w, you can say, right? So you have to find what? You have to find this a, or you can say h of j omega magnitude at, you can say that omega. Okay, this is very important to keep in mind. At omega equal to 10.5 w, right? What is the Fourier transform of this? That is very, very important. And you see again, they have given, this is nothing but one signal xt, right? And they have multiplied cos 10 wt, right? If any time domain signal is multiplied with the cos or sine whatever, right, you have to go for modulation property. That is nothing but a band pass signal kind of thing, right? Modulation property has to be used. So what is the Fourier transform of this? That is very important. So let me write here h of t. Okay, h of t is nothing but pi times of sine omega naught, sine wt. This is sine wt by pi t square cos 10 wt. Okay, so first solve this. Okay, please solve this. Okay, don't focus on 10 cos 10 wt, right? Because that is the different story. You can consider this is nothing but xt. Xt is what? Sine wt by pi t, a whole square. You know, in time domain, if there is a multiplication in time domain, see, same signal is getting multiplied. You can say that x1t times x2t. If it is multiplied, so in the Fourier domain, what will happen? In the frequency domain, it should be having the convolution of them. X of omega convolution x2 of omega. Okay. Now, what is the Fourier transform of sine wt by pi t? Okay, that is very important. Sine wt by pi t का Fourier transform क्या होता है? Directly, you should know that the Fourier transform is nothing but a rectangle from w to w in omega plane, that you have to remember. And the magnitude is 1, right? Okay, so you have to convolve two rectangles. This is quite conceptual question. So these are the two rectangles you have to convolve, right? From minus w to w, okay, 1 1 and 1 by 2 pi. You have to remember this 1 by 2 pi. Okay, and there is one more pi that also you have to take care of. Okay. Now, what you can do here is, you know that convolution of same, you can say convolution of rectangle, right? Okay, two rectangles, okay, will be the triangle if their width is same. You see, width is same, so it will be nothing but this minus 2w to w. Okay, understood? And what is the magnitude here, guys? Magnitude is going to be 2w times 1, right? You can say that it will be 2w upon 2 pi into pi, because there is a pi also. Okay, so this will give you, you know, it is going to be just giving you w only, right? I believe this is fine for all, because 2 gone, pi gone. So you have got this spectrum. So let me add one more page. Okay, so this spectrum you have got, right? Just take this spectrum. This is the Fourier transform of, okay, this signal, right? Let me show you this signal. Okay, simply pi times sine omega t wt by pi t. Okay, so this is nothing but 2w and this is W. Now you have to multiply this by what? Cosine, right? Cosine WT. What you will do here is, आप क्या करोगे यहाँ बताओ? कोसाइन से मल्टीप्लाई करवाने का मतलब है शिफ्ट एंड स्केल बाय हाफ. यू डोंट हैव टू राइट एनी एक्सप्रेशन हियर, जस्ट शिफ्ट कर दो. और क्योंकि आफ्टर ऑल यू हैव टू शिफ्ट दिस, राइट? तो आपको इसका, अगर आपको मॉड्यूलेशन प्रॉपर्टी लगाना है तो इट विल बी नथिंग बट शिफ्टेड बाय व्हाट. So you can shift this by what frequency? So you see here 10W, right? 10W, right? So 10W से अगर इसको shift करते हो तो 10W add करना पड़ेगा, subtract करना पड़ेगा, right? So you will get here and you will get here, yeah. And the magnitude is gonna, W by 2 you can. Okay, after applying the, so it is nothing but 10W, right? And what is this, guys? This becomes, this is nothing but what? 2 here. So if you add to 10, so it becomes 12W, right? And this is nothing but 10 minus 2, that is nothing but 8W, right? In this manner you can do it. So now what they are asking is you have to find the magnitude, okay, at magnitude at what? You see the question, actual question, the magnitude you have to find at 10.5W, right? So you have to find at this point. Let me highlight properly. You have to find the magnitude at this point, 10.5W. See, in the exam, you will be able to reach to this, this step, but this is a problem where you face challenges, right? You are not able to find the magnitude, okay? So how to find the magnitude? That is very important. So you don't have to write a straight line equation here. What you can do here is, you see this is the width. What is the width here, guys? 2W. So you can say that 2W correspond to what? What is the magnitude here, guys? W by 2. Okay. Now, what 10.5W, what is the width here then? You can see what is the width here. If you try to subtract 12 minus 10.5, 12 minus 10.5, which is nothing but 5, and this is 1, right? So 1.5W correspond to what? So you can say that 1.5W into W by 2 upon 2W, right? So it will be nothing but what, guys? Just simply you can say 1.5W by 2. I mean, just you say that this is nothing but 4, right? Now you can just take this guy and multiply with the, okay, this is nothing but A we have got. So अगर आप यहाँ रखते हो, so this is nothing but what? You can say that 1.5W into 10 by 4 cos 10.5WT. So you see this is nothing but 15W by 4 cosine. So exact answer we are getting, exact answer. There is no confusion at all. Okay. So answer for this question will be what? Option A. Okay. So remember, what is the concept here? The concept is, if there is a sinusoidal input, okay, the output will be sinusoidal, okay, provided the magnitude will be different and the phase might be different, okay, but the input frequency and the output frequency should match. That is the property of LTI system. ठीक है, 7 क्वेश्चन सिग्नल से आए हैं, मतलब आप समझ जाओ कि बहुत सारे क्वेश्चंस आए हैं सिग्नल से. ठीक है, ये क्वेश्चन मुझे काफी सही लगा. ओके, चलो नेक्स्ट. And you should know the procedure, how to find the Fourier transform quickly, how to apply properties of the Fourier transform. अब मेरा करने का तरीका ये है. I don't know how you do, right? That is. Next question is 58 question. Let us read the question first from the signal only. x1t equal to this given, ut plus 1.5. So I will be able to identify this is nothing but your pulse. A pulse from minus 1.5 to 1.5, right? The moment you read the question, you keep on plotting also. That is very important. This is x1t and x2t is shown in the figure below. Okay, ये x2t. What they are asking is the value. Okay, since they have given by t is nothing but the convolution of x1t and x2t. They are asking integration minus infinity to infinity by t is. What they are asking is the area. Area under output. अब बहुत सारे लोग क्या करेंगे इसमें, बहुत सारे लोग दे विल गो फॉर फोरियर ट्रांसफॉर्म्स, राइट, एंड दे विल बेस देयर टाइम. ये एरिया अंडर बाई टी पूछ रहा है, एंड बाई टी इज नथिंग बट अ कॉन्वोल्यूशन ऑफ टू सिग्नल्स. So how to find the area of output if there is a convolution, okay, of two signals? So you have to individually find the area of x1, area of x2, and the output area is going to be the product of two signal area, right? x1 and x2. That is the concept that you have to use. So आपको area इसका निकालना. What is the area of this guy? So 1 into 3, that is 3. Okay. What is the area of x2? So ये क्या है? Impulse है. Impulse का area 1. Impulse, there are 2 impulse, इसका एरिया 2. इस रेक्टेंगल का एरिया कितना हो जाएगा गाइस? विड्थ 2 है और ये 1, सो यू कैन से 2. व्हाट इज द ओवरऑल एरिया फॉर दिस? 2 + 2 + 1, दैट इज नथिंग बट 5. तो ये आ गया आपका क्या? A2. ये आ गया आपका A1. तो ओवरऑल एरिया कितना आएगा? आउटपुट का एरिया यू कैन से A बाई एरिया A1 टाइम्स A2, विच इज नथिंग बट 3 × 5, 15. आंसर इज 15. देखो 2 मार्क क्वेश्चन यू कैन गेट in fraction of second. ठीक है, तो we have done many questions. Next, I think all questions are done now. ठीक है, all questions are done. Okay, so we have done 7 questions, guys. Okay, and it took around 37 minutes or 35 minutes just because I am explaining you. If I am solving, so 7 question needs only how many minutes? You can say around 15 to 20 minutes maximum. ठीक है, क्योंकि कुछ क्वेश्चन में थोड़ा सा कैलकुलेशन है, बाकी तो सब डायरेक्ट है, राइट. तो आकाश इज आस्किंग कैन यू प्लीज टेक PYQ ऑफ QAT PG CO? नो, एक्चुअली आकाश, वी आर टॉकिंग अबाउट at this moment gate examination, because gate examination is on head, so that we can do, right? I'm not familiar with this QAT PG, right? You can directly reach to me. Okay, thank you guys. We will meet again with one of the set of question, you can say from electromagnetic or communication system. Hopefully communication analog से ले सकते हैं, devices से 23 का सारा कर देते हैं, right? Thank you.